our last lesson, we were looking at practice now 16. Okay, and we have stopped at question I part C. Correct? We completed part C already, right? Okay, so let's take a look at part D. Okay, so in part D, we want to find out what is the vector EF. And the vector EF is this vector over here. Okay, so the intuition that we have in terms of how we solve A, B, and C was that we look for an alternative path. Okay, so very likely the intuition is that you would think of trying to figure out what is ED, okay, and then after that find out what is DF. But the problem is that while I know what is DF because of part B, I do not know what is ED. Okay, and I'm not able to figure out what is ED based on the information that has been given to us. Because I only know that AD is 4B. Okay, I do not know what is this axis. And there's no ratio or whatsoever, okay, in terms of knowing what is ED. Therefore, going by this method itself is not going to be feasible. Okay, if you want to think of finding a path that will help you to find EF. Okay, so the other technique in terms of solving our vectors is to make use of similar figures. Okay, so we need to first realize that triangle EDF, this triangle here, is actually similar to triangle BCF. Okay, so point E is corresponding to point B, and then after that point D is corresponding to C, and then F is the one that's common. Okay, so why do we want to make use of our similar figures? Okay, because we do know what is the vector of FB. Okay, we can figure out what is the vector FB itself. Alright, so how is it that we first know that these are going to be similar figures? It is a very simple inference that we can get, okay, from the question itself, whereby we know that this ABCD is a parallelogram. So this line, okay, so this line AD to E is actually parallel to BC. So we know that this angle and this angle will be equal due to your alternate angles parallel lines property. And then we also see property of vertically opposite angles. Okay, so using our AA similarity test, okay, I can easily identify that triangle EDF is similar to triangle BCF. Okay, so let me write that down first. Okay, very often when you need to make use of similar triangle property, you don't have to prove it. It is very obvious. Okay, maybe not obvious to you now lah. Okay, but as you practice more, it will become obvious to you. Okay, to identify using AA similarity. Okay, so for your notes taking purposes, I'll just write down, okay, why is it that it is similar? Alright, that is because your angle FED equals to angle FEC, and angle EFD equals to BFC. By your AA similarity test. Okay. So very commonly in our vectors question, right, when you need to make use of similar triangles to help you to solve, you need not actually use, you need not go about proving, okay, the similarity, but you need to be able to identify. And to identify, we always use AA similarity test most of the time. Okay. Okay. So now we want to find out what is the vector EF. Okay. So this side EF, right, following this vertices that's given. Okay, EF is actually corresponding to BF. Right, so it comes out to be a pair, and that will be equals to DF over CF. Okay, why is it that we choose DF over CF? Okay, it is because we know what is the ratio given this information. Okay, that we covered on today's Thursday onward, Tuesday itself, right? Okay, so DF is actually equals to 1/4 DC. That day I mentioned that this means that the ratio of DF to DC is 1/4. Okay, which means that DF being 1 unit, your FC will actually be 3 units, so that the total DC is 4 units. Okay, so we make use of this ratio in terms of coming up with this formula over here. So DF over CF will be equals to 2 over C. DF over CF. Okay, that will be 1/3. Okay, hence your EF equals to 1/3 of BF. Okay, notice that I've not put in the vector itself. Okay, I'm just using the length, okay, as ratio. Because if you put in the vector, you need to be very careful about the direction. Okay, so EF as a vector will be 1/3, okay, of what? EF is in this direction, so it cannot be 1/3 of BF because it's going in the opposite direction. Okay, so it must be 1/3 of FB. Okay, and FB is equals to FC plus CB. FC, we have it in part C, which is 6A. And then the vector CB is this vector over here that's going downwards. It is the opposite direction of your 4B. So CB is a vector negative 4B. And then we simplify this. Okay, you can leave your answer in this manner, not an issue, or you want to extend it in order to get 2A minus 4 over 3B. That's fine as well. Okay. Right, so when it comes to vectors, normally, okay, our first intuition will be to try to look for alternative paths that will help us produce that vector. Like I mentioned just now, to find EF, likely we will think of ED plus DF. Okay, but we know that it is not feasible because we do not know and cannot find what is the vector of ED. Okay, so because it is not findable or cannot be found, okay, so we then look for some form of similar triangles. Okay, and since we are told that it's parallelogram, very likely you can apply your alternate angles property, your corresponding angles property, or your interior angles property. Okay. Shall we look at part 2A? Okay, so in part 2A, we want to find the ratio, okay, or the fraction of area of triangle EDF, okay, and also the area of triangle BCF. So in part D just now, we already figured that they are similar. So since we're looking for the ratio of the area, we have learned previously that for similar triangles, okay, the ratio of the area will just be the square of the length ratio. Okay, remember that? So for similar figures, A1 over A2 equals to L1 over L2 squared. Okay, if you remember formulas like that. And then for volume wise, we know that it will be Q. Okay, that was what we learned last year. Right? So in this case, we already know that the ratio of the length, okay, over here is 1/3. So when it comes to the ratio of the area, it will be 1/3 squared. So in part 2A, Okay, make sure there are brackets around the fraction, and then you square it, and then we get 1/9. Okay?
I watch the live stream.
Questions so far? Okay, then after that for part B, we want to find the ratio of the areas of triangle EDF, okay, and also the area of triangle ADF. Okay, so ADF is actually this triangle here, whereby they are missing this line segment. Okay, but you need to recognize that this is the triangle. Very obviously, from the visual aspect of it, we know that these two triangles are not similar. Okay, clearly they are not similar, right? Okay, so then how? That means in order to answer our part B question, we cannot make use of similar triangles. Okay, however, we do notice that if I want to really go and find the area of these two triangles, how would we go about doing it? Okay, we know the area of triangle is half times base times height. That's what we learned since primary school, yeah? Okay, so if I choose for this smaller triangle that the base is ED, okay, the height itself will be perpendicular to it, okay, this height over here. Alright, whereas for this triangle, if I were to choose my base, let me get a different color. Okay, if I get my base to be this one, I will notice that the height will have to be perpendicular. This is where I have to do the dotted line, extend it out. Okay, and I find that this thing itself will actually be perpendicular to this part. Remember, when it is triangles that look like this, okay, if I choose this as my base, my height I have to extend out in order to get the 90 degrees. Right? This is an obtuse angle triangle. Okay, so when I choose my base carefully, I notice that the height of both triangles are actually the same. Right? Then what would this actually imply when I try to solve this question? Okay, by applying the formula of half times base times height, for triangle EDF, it will be half times ED times height, okay, over half times AD times height. And the heights in this case are both the same. Okay? You cannot have it such that the heights are totally different. Alright, we need it to be the same because when I simplify this fraction, I can cancel out the half, I can also cancel out the height. Right, that's how we simplify our fraction. And therefore, our area of triangles in this case is simplified to trying to figure out what is the ratio of ED and AD. Okay? Then, just now, okay, because I know that this small triangle over here, the EDF, is actually similar to this triangle. Okay, and the ratio is 1:3. Down here, 1 unit, 3 units. And we know that BC, okay, is actually exactly in terms of vector to AD. Right? So actually, if this side is 1:3, down here will also be 3 units because ED and BC are corresponding sides for the two similar triangles. Okay, so because earlier on we said that triangle EDF and BCF are similar, we know that ED is corresponding to BC and BC is equal to AD because of parallelogram property. So therefore, our ED over AE or to be precise, the ratio of the area that we're trying to find will just be 1/3 itself. Okay, so yesterday, not yesterday, but on Tuesday I did mention that I skipped practice now 15. Okay, because practice now 15, I wanted to show two different methods of solving. Okay, practice now 15, the question itself should not be unfamiliar to you, because we have done this same kind of question when we did our A maths, okay, in coordinate geometry. Alright? Okay, so what we did in A maths, okay, usually they may have given you a diagram about how A, B, C, D as a parallelogram looks like. Okay, so in this case, sorry, I'm not going to draw it to scale, yeah? Okay, just drawing something to illustrate the idea that we're given. We have A, B, C, D, making sure that it is in an anti-clockwise or clockwise manner. Okay, our coordinates are 3, 7, negative 1, 2, and for D it is 5, negative 4. I want to find out what is the coordinates of this. What we have learned in our A maths is that using our property of parallelogram, we know that the diagonals, okay, bisect each other. That means that the midpoint of the diagonals are the same. Remember that? Okay, we did that in our A maths. So what we would have done in our A maths was that I need to go and find the midpoint of the respective diagonals. So since I do not know what is C, I will let C have the coordinates x, y, for example. Okay, and the midpoint of AC will be found by taking the x coordinate, summing them up, divide by 2. Likewise, the y coordinate, sum them up to divide by 2. Okay, that will be the midpoint of the diagonal AC. And then the midpoint of the diagonal BD is exactly the same thing, just with different numbers. Okay, expressing in this manner. And because of the property of parallelogram, we know that they are equal since diagonals bisect each other. Okay, and then we can solve, right? We see that the x coordinate will have to be the same, so 3 plus x over 2 will have to be 5 minus 1, 4 divided by 2 equals to 2. And then the y coordinates also have to be the same. Okay, that will be equals to negative 1. And then we solve, right? To find that 3 plus x equals to 4, so x equals to 1. Okay, and we find that our x coordinate is negative is 1 and our y coordinate is negative 9. Hence, we see that C has the coordinates 1, negative 9. Okay, so this is what we have done in A maths. Right? Could you have used this same method to actually solve this question in E maths? You can. Okay? Can you use vectors, which is what I'm going to show you, to answer this question in A maths? You can also. Okay, because we're all learning maths, alright, so there isn't any restriction at all. Okay, so just presenting to us the different methods, okay, to solve this. Alright, there is in fact a longer method, okay, which is to find the length, alright, of the respective sides and then equal to each other. Then you have to solve simultaneously. Okay, then that will be an entire heading itself. Right? So that was the reason why in A maths we learned this simpler method by making use of this property. Okay? So now that we are learning vectors, okay, we are going to learn vectors. Okay? Right? So what we can do is that because I have coordinates over here, and previously when we understand about position vectors, we can translate these coordinates into position vectors. That means that our vector OA will be 3, 7. OB is negative 1, 2. and OD is 5, negative 4. What we want to find out is the vector OC. Okay, so similar to how we start off in method 1, we let OC be equals to xy. Right? And because this is a parallelogram, okay, we know that the opposite sides are actually equal and parallel to each other. So because they are equal in length and parallel to each other, that makes the two vectors here to be equal itself. Likewise, the vectors AD and BC are equal. So up to you to choose which pair is it that you want to be equal. What I had chosen was to let DC equals to AB. Okay? Likewise, using our property of parallelogram. Okay, whereby we can conclude that the vectors have to be equal. Alright? And for the vector DC itself, okay, we know that it is equals to DO plus OC, and AB is AO plus OB. And DO is the negative of OD, and OC is our XY. AO is the negative of OA, and OB is negative 1, 2. Okay? Then it reduces to simple calculations of like matrices already, okay, of all your vectors. Right? So in this case, I can write it as negative 5 plus x, 4 plus y. Okay? And then we know that negative 5 plus x equals to negative 4. Get the exact same set of coordinates, okay, whereby C is is 1 negative 9. Okay. Any questions? Mention that you can either switch your methods for Emaths, A-Maths, but also pay attention to the instruction word. Okay, if the instruction word was that use vectors to solve, then you got no choice but to only use this method. Okay, so if they leave it open, then of course you can use either one. Right? There isn't quite a description to talk about this particular method. Okay, they may actually specify using vectors. Then you have to do this. They wouldn't have specified that this one as a method, okay? Because a bit strange to say use coordinate geometry, right? Right. So let's move on, okay, to practice now 17. In practice now 17, you're given that OP is equals to 9P as a vector. So OP is in this direction, okay, and that is 9P. And then OQ is actually 3Q, so this direction over here, this has a vector of 3Q. The reason why it's not labeled in the diagram is because likely, due to the way they have labeled T and S, it becomes very confusing. Okay, so if you're going to label your own diagram, you just need to hold that memory, okay, that how you label it and what it actually means. Then the question also mentioned that OR is equals to 1/3 of OP. In other words, OR over OP is 1/3 when I divide OP over. So that will mean that OR, okay, is 1 unit, OP is 3 units. So the ratio wise is 1:2, because total is 3 units. minus 1 unit, you get 2 units over here. Okay? And then for OS, it is equals to half of OQ. So in other words, OS over OQ is 1 over 2. So OS is 1 unit, OQ 2 units. So it's actually a ratio of 1 is to 1. Okay? So in part I, we want to find the vectors of PQ. Whereby PQ is this vector. Okay? And we know that to find PQ, we can do PO plus OQ. Right? Taking that path itself. Okay? So write that down. And PO is the negative of OP, so negative 9P. And then OQ will be 3Q. So that will be the expression for PQ. In order for us to find out what is RS, so let me just connect the point from R to S with a line segment. Okay, we know that this is the direction that we're looking at for RS. Okay, then we look for the path that will connect from R to S, okay, itself, and that will be RO and OS. Okay, if you want to, you can consider RP plus PQ plus QS. Okay, just that it's a longer path only. Alright, so just like from here, you want to go home, you don't fly to the moon first, then after you reach home, right? Okay, so you can just take a direct bus back home, right? Okay, so RS itself, find the shortest path and see whether is it even possible first. We know that it is possible because based on this ratio, I can find out what is this vector, and based on this ratio, I also can find out what is OS, right? So as a base, we know that RS is equals to RO plus OS first. Okay. And RO will have to be equals to the negative of OR. And using this information, then OR is actually 1/3 of OP. So negative 1/3 OP. And OS is half of OQ. And OP, we know that it is 9P. And OQ, it is 3Q. Okay, then of course we must always simplify our vectors. Negative 3P plus 3 over 2Q. Then for part 2, we want to find out what is TS. TS is this vector here. Okay. So there are two different pathways that are straightforward in terms of looking for TS. Either you go up from T go to R, then after go to S, or else you T go to Q and then go to S. So it's really up to you which path is it that you want to take. But more importantly, it must be something that is possible. Okay, RS, we already know the answer over here, so it's actually possible. Okay, but if you want to choose this path, which is what I will do, okay, take TQ and then after that QS, I must know what is TQ. And that is possible by this given information, whereby we know RT equals to 1/3, sorry, 1/4 of RQ. In other words, RT over RQ equals to 1 over 4. So this is 1 unit, TQ will have to be 3 units. Okay. So to solve that, let me write down TS equals to TQ plus QS, and our TQ is actually 3/4 of our RQ. Okay, because TQ is 3 units, your entire RQ is 4 units. Okay, so 3 out of 4 of the entire RQ. Okay, and then your QS, okay, is actually half of QO. Because we mentioned that this is 1 unit, this is 1 unit. So QS itself will be half of the entire QO. Okay. Then we need to go and find out what is RQ and QO. Because we don't have RQ and QO already. Okay. So to find out what is RQ, you may consider having RP plus PQ. And then after that for QO, that will be the negative of OQ, so therefore negative 3P. Okay. Okay, so RQ will be RP plus PQ. And our RP is equals to 2/3 of OP. And our PQ, we had already found that it is plus 3Q minus 9P. And this simplifies to negative 3 over 2Q. And 2/3 of OP will be 2/3 times 9P. And then it reduces to trying to simplify our working x. Okay, let you read through and follow through first before I go into the next one. Okay. So even if you were to decide, okay, that you don't want to find TS by taking TQ plus QS, you want to go the other way round, which is to do TR plus RS. While yes, we have RS over here, okay, for us to find out what is TR, we still have to make use of this information, and this information requires us to know what is RQ. Okay, so you cannot run away from the tediousness of the solving process, where the tediousness was really to find out what is RQ. Okay, so this entire thing still needs to be done actually. You understand? Okay. But of course, if you want to, you can separate out the calculation, find RQ first, then put it all in. It may not always be as straightforward as having to neatly put it all in one paragraph like that. Okay? Questions? Alright. Okay, last question. Okay. Okay, so this one is not that easy, right? And it's not intuitive because there's no vectors given to you. Okay? So you're given a diagram and told that PQRS is a quadrilateral. Okay, and PQRS is actually PQRS over here. Okay, it may not look like your conventional quadrilateral. Okay, but it is still a four-sided figure, and all four-sided figures are called quadrilateral. Okay, so it says that A, B, C, D are midpoints. That means that they all cut, okay, halfway, right, for whatever line segments that they are seated on. Okay, so for C and D, right, so we need to recognize that. If you don't want to clutter your diagram, okay, just make sure you remember all this information. No need to draw too much of those strokes now. Okay. So in part I, we want to show that PR is parallel to AB and PR equals to 2AB. Okay, so how do we go about showing that PR is parallel to AB? We have known that in vectors sense, when it comes to it being parallel, this will mean that the vector PR must be a scalar multiple, okay, where I don't know what is that scalar, of the vector AB. Okay, so in order to show parallelness, whatever that word is, okay, in order to show that they are parallel, we need to actually have this statement at the end, and before we conclude that they are parallel. Okay, and in fact, with this information, very likely your K is supposed to be 2. Okay, but the problem is that we are given no vectors at all. So how are we supposed to even introduce vectors into this question? Okay, so maybe let me declutter this up. Okay, have a clean diagram. So we need to define certain things and introduce it into this question. Okay, we don't have any coordinates. So without coordinates, we cannot do any position vectors also. But we can borrow the idea about position vectors. Position vectors, we always have a reference point, and the reference point is our origin. Correct? But now we don't have our axis. We just need to determine an origin ourselves. And the origin, why not we choose Q? Okay? So instead of having origin, we let Q be the reference point. Okay? So we define such that we can let QR be a certain vector, whatever letter you choose. Okay, so I define it to be A, and we let QP equals to B. So this shall be a vector A, and this shall be a vector B. Okay. Okay, sorry. My bad. I don't want QI. Sorry. I read wrongly. I meant QA and QB. If you do QR and QP, then you will deal with fractions. We don't want that. Okay, sorry, my apologies. A and B. Okay? Yeah, why I do that? Okay, because then I can find out what is AB, which is going to be AQ plus QB. And AQ is negative of QA, and QB is B itself. Okay, so I figure out an expression for AB. Right? Now I need to do the same thing to figure out an expression for PR. Okay? So for PR itself, which is over here, you can observe the path will be from P to Q and Q to R. Okay, so what exactly is the vector PQ and what is the vector QR? We make use of what we have already defined, and knowing that A and B are the midpoints. So because they are midpoints, that means that this vector QP will have to be 2 times of B, and QR will have to be 2 times of A, which means that our PR will be PQ plus QR. Okay, and PQ is negative 2B and QR is 2A. Okay, yeah. Yeah, makes a negative sign. Negative B. Wait. So I don't understand you.
So it's AB, right?
AB.
So A to Q is negative 3 and Q to B is positive.
AB. Sorry, repeat that. Negative B
Plus A, correct?
plus A. Yes, A. But then QA is, oh, I labeled this wrongly. Yeah, I labeled this wrongly. Sorry. Yeah, I labeled this wrongly. Okay. Then the rest of things are okay. Good observation. Okay, so we have PR equals to negative 2B plus 2A, which is, if I were to factorize out the negative 2, it will be B plus B minus A. Hang on, did I make a mistake again somewhere? Oh, because just now I labeled wrongly, so this was not correct. Sorry. QP is 2A, QR is 2B. Okay, PQ plus QR. Okay, and then 2A negative plus 2B. Okay, then after we can factorize out the 2 and we get negative A plus B. Okay, so PR is 2 times negative A plus B. And negative A plus B is none other than your AB. Okay, so we have proven over here that since PR is a scalar multiple of AB, therefore PR is parallel to AB. Okay? And when it comes to the magnitude, okay, we know that the magnitude of PR is equals to the magnitude of 2AB. Okay, so magnitude, another expression will be PR instead of putting the modular sign. These strokes are actually what we call modulus, so if I will spell that out, MODULUS. Okay, we used to cover modulus in our A-Math syllabus, okay, but no harm in learning. Okay, modulus simply what it does is that it makes a number, especially when it's negative, into a positive number. That's all. Okay, simple concept. So put strokes around it, change the negative number to a positive number. But then if you put it around the positive number, it will still remain positive number. So that's what modulus do. Okay, just makes number positive. That's all. Okay, so if down here were to have been a negative number, putting this sign will have to make it positive. So end up must be a positive number. But since it's already positive, it will maintain positive. So therefore, we have shown that PR equals to 2AB as well. Okay. Right? For part 2, okay, you want to show that ABCD is a parallelogram. Okay, and in order to show that ABCD is a parallelogram, we can go by definition, which is that AB and CD must be parallel to each other, BC and AD must be parallel to each other. Okay? But in order to show that AB is parallel to CD, okay, it will require us to go through the same thing again. Right? Okay, but I don't want us to do that. We just make things simpler. We can say that using the same reasoning in part I for triangle SPR. Okay, so what this sentence covers is that you're going to do the exact same thing as what we did in part I, just that instead of using Q as our reference point, our S over here becomes a reference point, whereby I have SC defined to be a vector C, SD become a vector D, and then it's really same thing again, just with different letters, that's all. Okay? If you were to pursue mathematics at a higher level, very often mathematicians are lazy also, they also write things like that. Okay? In fact, in my entire life doing mathematics degree, right, the textbook, okay, you buy it so expensive, $100 for one textbook. Okay, then everything when you want to prove, they always say, what do they say? It is trivial. Yeah, they use this word trivial. To me, it was never trivial at all. Then they never show anything, and you pay $100 for this textbook. Everything tell you that it's trivial. Yeah, it's very frustrating. Okay, so maybe I was not highly skilled enough to understand the trivial stuff. Okay, but then okay, it was a textbook for a reason, right? I didn't understand why is it trivial. Okay, but instead of writing trivial, okay, we just say it's better lah. Okay, so using the same reasoning in part I for triangle SPR, okay, we can show that PR equals to 2DC. Okay, then so since PR equals to 2AD equals to 2DC, okay, then AB must be equals to DC. Okay, because they are all equal one, right? So by comparison, AB must be equals to DC. And therefore, I'll continue here. AB is parallel to DC. Okay, and AB equals to DC. So instead of proving two pairs of parallel lines, okay, we are restricted or we have difficulties in proving that BC equals to AD because of the lack of information. Alright, so an alternative way when it comes to proving parallelogram is that if I have one pair of parallel lines and they are confirmed equal in length, okay, which is what I'm doing over here, AB is parallel to DC and they are equal in length, we can conclude that ABCD must be a parallelogram. Okay. And the way we go about proving this parallelogram idea, okay, is somewhat a short preview to our very last chapter in A-Maths, okay, when we do plane geometry. A lot of proving. Okay. Yep, and that's all when it comes to vectors. Okay, so homework. Homework naturally follows. Okay. Want you to do exercises. Exercise 5B, sorry, 5C. Question 6A, C. 7B, 8A, 11 and 12. Okay, and then for exercise 5D, question 9, 12 and 15. week. Then Friday I don't even see you. And how? Like that? Huh? Friday you want to bring and submit? You all Friday want to bring and submit? Will you all remember to bring or not? Alright, I mean I want to take into consideration as your WA, okay? And Thursday HBL. Friday, okay? Friday please bring and then submit to Mingsan, Mingsan help me put inside by. Okay? Okay, and that's all for E-Maths. Aren't you glad you finished the syllabus already? Okay, chapter 5 is the very last chapter for E-Maths, Alright? So for the next few weeks, okay, we are going to just be finishing our A-Maths syllabus already. Okay, so tomorrow please bring your A-Maths textbook, okay, volume B, and we will continue with a new topic called integration. Okay, I strongly suggest that you bring along that formula booklet that I have given you, okay, because it's more formulas. And integration is trying to go opposite to our differentiation. So it's a bit undoing whatever we have done for differentiation.